Everything is spinning right now. Earth rotates once every 24 hours. That's why we have day and night. Simple enough. But Earth also travels around the sun. Takes a year. That's an orbit. The sun, it's moving too, orbiting the center of our galaxy. Takes about 200 million years for one lap. And the galaxy itself is rotating, the whole thing. Billions of stars all going in circles around the center. Look at other galaxies through a telescope. They're spinning too, almost all of them. Giant spirals. Look at weather patterns. Hurricanes rotate. Tornadoes rotate. Even that little whirlpool in your bathtub rotates. So here's the question. Why does everything spin? Why is rotation so common in the universe? Why don't things just move in straight lines? And here's a better question. If planets are orbiting the sun, and moons are orbiting planets, and everything is moving in circles around everything else, why doesn't it all crash together? Let me show you. The moon is moving around Earth right now, circling, orbiting. Why doesn't it fly away into space? Why doesn't it crash into Earth? It's moving fast, about 2,000 miles per hour. So why the circle? Why not a straight line? Two things are happening at once. The moon wants to go straight. That's its natural motion. But Earth pulls it. Gravity, constantly pulling toward Earth's center. The moon is falling toward Earth while moving sideways. The combination makes a curve. And if the speed is just right, that curve becomes a circle. The moon falls around Earth instead of into it. This is an orbit, continuous falling that never lands. The moon has been doing this for billions of years, falling toward Earth, missing, circling, never crashing, never flying away. Same thing with Earth around the sun. We're falling toward the sun right now, but we're also moving sideways, 67,000 miles per hour, fast enough that as we fall, the sun's pull curves our path into a circle. We orbit instead of crash. Every planet does this. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all falling toward the sun, all moving sideways, all orbiting. The balance between falling and sideways motion creates stable circles that last billions of years. But where did that sideways motion come from? Why is everything already moving when it starts falling? Go back to the beginning. The universe started with an explosion. Everything flew outward. Energy became matter. Particles formed. Eventually atoms, mostly hydrogen. These atoms spread through space, formed enormous clouds, gas clouds light years across, just floating in the darkness. These clouds weren't still. Nothing in the universe is perfectly still. There's always some motion, a push from a nearby explosion, a pull from a dense region, temperature differences, shock waves from dying stars, random disturbances. All of this creates movement. So the gas cloud is drifting slowly, different parts moving different directions. The cloud isn't solid, it's gas. Different regions can move independently, some drifting one way, some another, some up, some down. Chaotic motion. Now gravity starts working. Parts of the cloud that are slightly denser pull harder. They attract more gas, get even denser, pull even harder. A feedback loop. The cloud starts collapsing, slowly at first, then faster. Gravity pulling everything inward. As it collapses, something important happens. Remember, different parts of the cloud are moving in different directions. As they fall inward, they bring that motion with them. Some of that motion cancels out. Left motion cancels right motion. Up cancels down. But not all of it cancels. There's always some net rotation left over. The cloud as a whole has some spin, maybe tiny, maybe barely noticeable, but it's there. Watch an ice skater spinning, arms stretched out, rotating slowly. Now watch what happens when they pull their arms in. They spin faster, much faster, way faster. They didn't add energy, didn't push off anything. They just moved mass closer to the center. The rotation speeds up automatically. This is conservation of angular momentum, one of the fundamental laws of physics. Anything rotating wants to keep rotating, and when rotating mass moves closer to the center, the rotation accelerates. The collapsing gas cloud does exactly this. As it falls inward, as the cloud gets smaller, any rotation it had speeds up dramatically. What started as barely noticeable drift becomes rapid spin. The cloud begins rotating faster and faster, and as it spins faster, something else happens. The cloud flattens. Material that was spread through 3 dimensions gets squeezed into 2, into a disk, a rotating disk. Picture pizza dough. Throw it in the air, spinning. What happens? It flattens, spreads out, becomes a disk. The spinning motion pushes material outward, but only in the plane of rotation. The dough becomes flat and circular. Same thing happens to the gas cloud. It flattens into a spinning disk. Material spreads outward in the plane of rotation, gets compressed vertically. You end up with a thin, rotating disk of gas and dust. This happens everywhere in the universe. Every collapsing gas cloud becomes a rotating disk. Not sometimes, not maybe, always. It's built into the physics. You can't avoid it. Collapse plus any initial rotation equals a spinning disk. Automatic, inevitable. At the center of this disk, gas piles up. More and more material falls inward. The center gets compressed, dense, hot. Temperature rises, pressure builds, millions of degrees. Eventually the center gets so hot that hydrogen atoms start fusing together. Nuclear fusion begins. Hydrogen becomes helium, releases enormous energy. A star is born. And that star is spinning, has to be. It inherited the rotation from the collapsing cloud, can't avoid it. Our sun formed this way 4.5 billion years ago. A giant gas cloud somewhere in our galaxy started collapsing, spun faster as it shrank, flattened into a disk. The center became hot enough for fusion. The sun ignited, and it's been spinning ever since. One rotation every 25 days. But the disk didn't disappear when the sun formed. Plenty of material remained, gas and dust orbiting the newborn sun, all moving in circles, all in the same direction, the direction of the original cloud's rotation. This disk is called a protoplanetary disk, and it's where planets form. Over millions of years, particles in this disk collide with each other. When they collide gently, they stick together. Dust grains stick to other dust grains, make bigger clumps. Those clumps collide with other clumps, stick together, make even bigger clumps. Slowly, very slowly, these clumps grow. Dust grains become pebbles. Pebbles become rocks. Rocks become boulders. Boulders become mountains. Mountains become small planets called planetesimals. Eventually, planetesimals collide and merge into full-size planets. This process takes millions of years, but it happens. And when it's done, you have planets orbiting a star. And here's the critical point. Every planet was already moving before it became a planet, already orbiting, because it formed inside a rotating disk. The particles that stuck together to make the planet were already moving sideways, already circling the sun. When they combined, they kept that motion. The sideways motion was built in from the start, inherited from the rotating disk. This is why all 8 planets in our solar system orbit the sun in the same direction. They didn't choose to orbit that way. They had no choice. They all came from the same rotating disk, same spin, same direction. Mercury goes around one way, then Venus, then Earth, Mars, Jupiter, Saturn, Uranus, Neptune, all circling the same direction, all following the original rotation of the disk they formed from. If the planets had formed separately from different clouds, they'd orbit in random directions, some clockwise, some counterclockwise, different angles, different planes, total chaos. But they didn't form separately. They formed together in one disk from one collapsing cloud. So they all orbit together, same direction, same plane, like grooves on a record player. And look at the plane they orbit in. It's flat, very flat. All the planets orbit within a few degrees of the same plane. Why? Because they formed in a flat disk. The disk was maybe a few million miles thick, but billions of miles wide, very flat. Planets formed in that flat disk, so their orbits are flat too. The planets themselves spin. Earth rotates once per day. Mars rotates once per day. Jupiter rotates every 10 hours. Saturn every 11 hours. They all spin. Why? Same reason everything else spins. As each planet formed, as material fell onto it from the surrounding disk, that material brought rotation with it. Not perfectly balanced, some net spin. As the planet grew, that spin increased. Conservation of angular momentum again. The planet spun faster as more mass accumulated. And once spinning, it never stopped. Still spinning billions of years later. Even moons formed the same way. When planets grew large enough, some of them created their own small disks of material, mini versions of the sun's protoplanetary disk, material orbiting the planet. That material collided, stuck together, grew, became moons. Jupiter has dozens of moons. Saturn has dozens, all orbiting, all moving sideways, all formed from rotating disks around the planets. Our moon probably formed differently. Most scientists think a giant impact happened. Something the size of Mars crashed into early Earth. The collision was violent, blasted enormous amounts of material into orbit around Earth. That material formed a disk, a hot disk of vaporized rock orbiting Earth. Over time, that disk cooled. Material collided, stuck together, became the moon. Different origin than other moons, but same result. A disk, rotation, and orbit. The moon has been circling Earth ever since. Same direction Earth spins, because it formed from Earth's rotating debris. Go bigger, much bigger, galaxies. Our galaxy, the Milky Way, is a spiral, a massive rotating disk. Hundreds of billions of stars, all orbiting the center. The sun is located about halfway out from the center. It takes about 200 million years to complete one orbit around the galactic center. We're moving fast, about 500,000 miles per hour, circling with all the other stars in our region. Why is the galaxy spinning? Same reason everything else spins. It formed from a collapsing gas cloud, a truly enormous gas cloud, millions of light years across. That cloud had some rotation, very slow rotation, barely noticeable. But as it collapsed under its own gravity, that rotation increased. The cloud spun faster, flattened into a disk. Stars formed in that rotating disk. They've been orbiting the galactic center ever since, for billions of years. Other galaxies show the same pattern. Most of them are spirals, rotating disks of stars, all spinning. Some galaxies are elliptical instead of spiral, more blob-like, less organized. But even those have rotation. The stars inside them are moving, orbiting the center, just in more random paths, but still rotating. Rotation is everywhere because gravity is everywhere. And whenever gravity pulls things together, whenever anything collapses, Any initial motion gets amplified. Tiny spins become huge spins. Barely moving becomes rapidly rotating. Can't avoid it. Physics makes it happen. This is why the universe has structure, why it's not just a uniform fog of gas spread evenly through space. Because rotation prevents complete collapse. Things fall inward, but they also move sideways. The sideways motion keeps them from crashing all the way together. They orbit instead. They spread out into disks. Structure forms. Organization emerges. Galaxies, stars, planets, all from gravity plus rotation. Without rotation, everything would just collapse straight down. Gas clouds would compress into dense spheres. No disks, no planets orbiting stars, no solar systems, just massive balls of gas and stars. Probably no place for life to emerge. No stable platforms, no planets with surfaces, nothing long-lasting and stable. We exist because the universe spins. Now back to that question about crashing. Why don't planets crash into the sun? Why doesn't the moon crash into Earth? If gravity is pulling them together, why don't they eventually collide? Because of that sideways motion. That orbital velocity. The moon is falling toward Earth right now. This very second, gravity pulls it constantly. But the moon is also moving sideways, about 2,000 miles per hour, fast enough that as it falls toward Earth, Earth's surface curves away beneath it. The moon keeps missing Earth. It falls around Earth instead of into it. Drop something and it falls straight down. That's because it has no sideways motion, just falls. But throw something sideways while dropping it, what happens? It follows a curved path, falls and moves sideways at the same time. The combination makes a curve. Now throw it faster, harder. The curve gets longer, flatter. Throw it fast enough and the curve matches Earth's curvature. The object falls around Earth instead of into it. That's an orbit. The moon is moving sideways at exactly the right speed, fast enough that its curved falling path matches Earth's curved surface. So it never gets closer, never crashes, just circles forever. Slow the moon down even a little and it would start spiraling inward, get closer and closer to Earth, eventually crash. But it's moving just fast enough to maintain its orbit. The falling motion and the sideways motion balance perfectly. Same thing with Earth and the sun. We're falling toward the sun right now. Gravity pulls us constantly, but we're moving sideways at 67,000 miles per hour, just fast enough that as we fall toward the sun's surface curves away from us. We keep missing. We fall around the sun instead of into it. Slow Earth down and we'd spiral into the sun, get hotter and hotter, eventually burn up. Speed Earth up and we'd fly away into deep space, get colder and colder, freeze. We're right in the middle, the perfect balance, just right for a stable orbit. This balance exists for every planet, every moon, every satellite, every object in orbit around anything else. They're all falling, all being pulled by gravity, but all moving sideways, just fast enough to miss, to orbit instead of crash. And these orbits are stable, incredibly stable. Earth has been orbiting the sun for 4.5 billion years. Same orbit, same distance, same speed, never crashed into the sun, never flew away into space, just circling endlessly. The moon has orbited Earth for over 4 billion years. Same path. The moon is very slowly drifting away because of tidal effects, but incredibly slow. The orbit is essentially stable. Why are orbits so stable? Why do they last billions of years without changing much? Because there's nothing to slow them down. Space is empty, almost perfect vacuum, no air, no friction, no resistance. When something moves through empty space, nothing stops it. The motion continues forever. Energy is conserved. Momentum is conserved. The orbits persist. On Earth, everything slows down eventually, friction, air resistance, things rubbing against other things. Energy gets converted to heat. Motion stops. But in space, none of that happens. Objects keep moving, keep orbiting forever, unless something crashes into them. This is the natural state of the universe. Once something starts spinning, it keeps spinning. Once something starts orbiting, it keeps orbiting. The motion never stops. On Earth, we see the same spinning pattern. Hurricanes spin. Why? Because Earth itself is spinning. Earth rotates once per day. That means different parts of Earth are moving at different speeds. The equator moves fast, about 1,000 miles per hour. Points near the poles move slower. So air near the equator is moving fast. Air near the poles is moving slow. When air flows from one latitude to another, it's moving over ground that's rotating at a different speed. The air gets deflected, curves, starts rotating. This is called the Coriolis effect. It's why hurricanes spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Add heat from warm ocean water. The warm water evaporates, rises, creates low pressure. More air rushes in. That air is rotating. The rotation organizes into a spiral. More heat adds more energy. The spiral spins faster. Hurricane, giant rotating storm, winds over 100 miles per hour. Tornadoes form similarly. Thunderstorms create powerful updrafts, rising air. If wind speed is different at different heights, the rising column starts rotating. It gets stretched vertically, and conservation of angular momentum kicks in. As the column stretches, it spins faster, much faster. Tornado, violently spinning column, winds over 200 miles per hour. Even water going down a drain shows the pattern. Any slight disturbance creates rotation. Once started, that rotation continues, gets amplified as water spirals down. Same principle. Everything spins because the universe started with motion and gravity amplified it. Turned tiny random drifts into organized rotation. Turned chaos into structure. Small spins became large spins. The pattern repeats at every scale. Small gas clouds collapse and become spinning stars. Large gas clouds collapse and become spinning galaxies. Disks of gas around stars become orbiting planets. Same physics, same result. It goes back to the beginning. The early universe had motion, random variations, tiny differences in how things were moving. Those motions never stopped. They grew, got amplified by gravity, organized into the rotating structures we see today. Look up at the sky. Every star you see is spinning. Every planet around those stars is orbiting. Every galaxy is rotating. All connected by one simple principle. Spin is conserved. Collapse amplifies spin. Rotation creates structure. You're standing on a spinning planet. That planet is orbiting a spinning star. That star is orbiting in a spinning galaxy made from material that came from spinning gas clouds. The spin goes all the way back. That's why everything spins. Not because something actively makes it spin, because once it started, nothing stopped it. And gravity made it faster, turned tiny random motions into grand spirals, turned chaotic drifts into elegant circular orbits. Spin is fundamental, built into the fabric of the universe, from the smallest whirlpool to the largest galaxy. Same pattern, same physics.